Yellow peeps. So before we have a look at displacement time graphs, which is what we'll be looking at in this video here, just want to quickly recap. So you should have already had a look at what is meant by our SUVAT, so displacement, our velocities, our acceleration, and obviously we measure time usually in seconds. So what we will have to do for our displacement time graphs is maybe draw a graph to represent how an object, usually a person or a lorry or something, a vehicle, travels over time, how its displacement changes. Now remember, this is straight line motion, so everything in these scenarios really is moving in a straight line. So its displacement, again, which is the distance but including the direction, can be positive if it's moving in one direction, and then if it's in the other direction from where it started, then it may have a negative displacement. Again, so you measure displacement from a certain place, and if it's moved to one side, then it may be positive. Let's just say if we move measuring from O here, then if something moves out here, that may be a positive displacement. It may move all the way back, so it's to the left-hand side here where it started, so that would be a negative displacement. And it's just the distance that you are away from your original point. Again, basic things like speed is distance over time that we should already know. That also works for velocity. Velocity is just speed with a direction as well. So I mean, if you're driving maybe forward in a car, that would probably be a positive velocity. If you were reversing a car, that would probably be a negative velocity because you're going backwards. Again, this is all in straight lines, so either to the right and to the left or forward and backwards, something like that. So velocity then is just your displacement over time, because displacement is kind of like distance. Again, it could be positive or negative. So if you've got a negative displacement, then that will probably lead to a negative velocity. So in these graphs, when you're showing the change in displacement over time, then your gradient, the gradient of the graph, represents the velocity, because that will be the change in displacement over time. Your difference in y's over difference in x's will be the difference in displacements over the difference in times. So again, remember the difference between displacement and velocity instead of distance, and that's meant to be speed, sugar. Distance and speed. I will correct that now. Go. Okay, so let's have a look at an example of what we will have to do. So usually the graphs are given to us. They may ask us to sketch this graph. Fairly straightforward though. So lorry at recycling plant leaves its base, the origin, travels east. So again, if you imagine this on a map, it's just to the right, I guess, to collect the goods. It will then recycle and then returns to the base. After waiting for instructions for the lorry, it then travels west, so it travels in the opposite direction for the goods, for recycling, at time t seconds. The displacement of the lorry from the origin is x meters, so that just says at any time we call the displacement x, which is why it's called x. We usually use s, but sometimes in physics they use x as well, so just so you're used to that. The displacement graph of the lorry is shown below. So as you can see here, it starts off at the origin, so that's when it's at its base, and then the further that it moves up there, over 30 seconds time, it travels 600 meters away. Here then it's flat, so that represents a constant displacement. Is staying in the same place. Its displacement isn't moving. Again, you can think of that as a distance, really. Its distance away from the base isn't moving, so it's stationary, and then it travels back towards the base. It's then in the base between 110 and 140 seconds, so it's 30 seconds in total. It then goes in the opposite direction, so it's got a negative displacement. It travels 400 meters in the other direction, waits there for a while, and then comes back to the base. Okay, so what they'll do now is they'll probably ask you several questions on this. So for example, state the total distance travelled. So again, its displacement will change. Its displacement over the 250 seconds is actually 0 because it's back where it started. So even though it's travelled all that way, its displacement is technically 0 because it's back where it started. So The total distance travelled, however, you've got to add up your 600 travelled there, your 600 travelled there, your 400 and your 400 travelled there. So you've got two lots of 600 and you've got your two lots of 400, which altogether make that 2,000 metres or 2 kilometres in all that it's travelled. Fairly straightforward. Question B, calculate the speed of the lorry during the interval 70 to 110 there. Now again, think of the speed. He's travelling back towards the base there, that lorry is travelling back towards the base, so it would have a negative velocity, technically it would have a negative velocity, but speed is just the speed that it's travelling at, so the direction doesn't matter, speed will always be positive. If it has velocity there, then we would have to do, it's this displacement over time, which would be minus 600 over the 40 seconds that it has travelled for. But in this case, for the speed, you just use distance over time. And the distance it would have travelled in this period here is 600 metres. And it's taken it 40 seconds. Bit of quick maths there, I believe should be 15 metres per second it was travelling at there. It travelled 600 metres in 40 seconds. There we go. So speed will be positive. Technically, if there was velocity, that will be negative 15 metres per second because it's travelled backwards 600 metres. Again, then for question C, calculate the velocity in that period there. Well, luckily it's an upslope, so that is a positive velocity. So it travels forward. So its velocity then, it travels back towards the base, so it's travelling forwards now in the positive direction. 20 metres, so it'll have a positive displacement there over sugar and spice. It's not 20 metres it's travelled because it's gone from minus 400. It's gone from minus 400 back up to 0, so it's travelled 400 there in the positive direction, and that should give us 20 metres per second there. So again, the same as the velocity, but it's in a positive direction, so that would always be the same as the speed. Speed, the direction doesn't matter. Velocity, it does. Okay, so just another quick thing on these graphs, curves. You can have a curve, so if for example you've got some axes for your displacement and your time, maybe your displacement's in meters per second and your time's in seconds, then you can have a curve, maybe if it's curving upwards like that, then that just shows that it's accelerating, because the displacement is getting further and further and further away, it's getting steeper as time goes on. So it's not a constant speed with a straight line. If we have a look at these with a straight line, the distance is constantly getting further away. In this case, it's actually speeding up. Similarly, if you have another curve, it could be decelerating, maybe it could be going like that. Then that would show that it's decelerating. You may have to check my spelling on that. There. Thank you very much.